I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics, medicine, nature,
or
Space. Time.
The brain.
Life. The universe.
Hello, this week we're taking to the road.
Before a child is born, right the way through to old age, air pollution is adversely affecting health.
We'll be asking, how clean and safe are our roads?
Congestion is a fact of life these days in cities. But what people find difficult to accept is that the journey time from day to day will change, and they might allow 45 minutes to get to a meeting one day, and the next week it'll take them 90 minutes.
How is traffic controlled in our towns and cities?
We believe that the technologies already exist for transportation to be zero carbon, zero deaths, and zero waste.
And how can science make roads better? I'm Katie Haylor, and this is The Naked Scientists.
The Naked Scientists podcast is powered by ukfast.co.uk.
First up, how do you go about actually making a road in the first place? I put this question to civil engineer Julian Lamb, Deputy Project Director for the A14 working on behalf of Highways England. So, donned with a whole load of personal protective equipment, we drove down to a section of the construction works to take a closer look at what literally goes into a road.
We're halfway between two of the bridges that we have on the scheme. We are constructing a dual carriageway here with 3 lanes in each direction, so you can see the different stages of construction.
Underneath the black layer that I can see that I would recognise as a road surface, you've then got a pretty thick brown grey layer. What happens under that then?
The concrete layer is founded on a ground improvement layer. It's a gravel, and laying that as your foundation to the road pavement that we're stood on.
Before you start building, what kinds of factors would you need to take into consideration?
Great deal of consultation is necessary, and in fact a scheme of this size is subject to a development consent order. Some of the main things are obviously the landowners that you're having to compulsorily take land from, the heritage, so there's an archaeological mitigation that we have to do, and also environmental and ecological mitigations that we have to do in advance of being able to access the site to carry out the work that we need to do. And in fact the borrow pit that we came past before, we found some woolly mammoth tusks and woolly rhino skulls.
So what about ecological considerations? Because when you're building a road, arguably you're inconveniencing people for the construction time, but I guess you could also be inconveniencing wildlife, right?
Yes, that's very much the case, and we've got some protected species that we've been looking after here. There's reptiles with the great crested newt, and we've had extensive areas of amphibious fencing that we've had to put in as a temporary measure and also as part of a permanent measure for the scheme. Also got some water voles, another protected species, and we have been creating some new habitats especially for the water vole, which meant that we had to trap them and keep them in a safe place while we were building the new habitat. We've also, as part of the scheme, we're reintroducing twice the amount of trees that we're removing. We're planting around 1 million trees as part of the scheme. Our aim for the project is to become biodiverse net positive.
Once you've done all of that, literally how do you make a road?
The first thing we have to do is to safeguard the site, and so we have to create a boundary to make sure that it's clear where our site is and where the members of the public can be. There are a whole series of utilities that we have to divert as a necessary part of the scheme. But once you've got the footprint, we've got a number of structures to build, some bridges to take existing side roads or farm tracks and take them up out of the way of the new A14.
You're having to consider people who need to use the area near the new road all the time that you're actually building it, right?
Yeah, we have to maintain existing accesses, so there are a number of side roads that we have to construct. We've got 35 new structures to build on the project, and we're having to do some modifications to another 35 on the scheme. We have to make sure we look after the water. So the first thing is to do pre-earthworks drainage, and that's to provide a cut-off. It might be a V-ditch, it might be a filter drain with stone that takes water down into an underlying pipe to make sure that we've cut the water off before it gets into the main trace.
Because earlier you said to me that water is the enemy when it comes to building a road, is that right?
Well, not so much the enemy, but we have to make sure that we've made provision into how water is going to land on the surface and how it's cast to the side. So we have to just manage it during the course of the project. Once we've done that, we then set about doing the bulk earthworks. Now, normally on a scheme, you would try and balance your cut areas where you're going below the existing ground with your fill areas where you're going above the existing ground. What you don't want to do is to have surplus material you've got to dispose of, and you don't particularly want to import material. That's the normal situation. Because we are in a floodplain, this project is built on an embankment, so we have to import material, which we're doing from locally sourced borrow pits along the trace to keep haul distances as short as possible. That saves on money, keeps the haulage off the existing road network.
I guess you also have to consider the environmental impact of actually doing the work. If you're accessing materials locally, you've got less stuff to haul, which means you're using less petrol or diesel or electricity to actually move the stuff.
That's very much the case. We then do post-earthworks drainage, which will sit linearly with the project in the centre reserve or in the verges of the pavement. So we're now in a position that we can start building the road. It's the first granular layer of material that we start with, which is about 600 millimetres thick. We then have a cement-bound concrete in 2 layers, which is about 350 millimetres thick. And then we have an asphalt pavement that sits on top of that, which is about 180 mil thick, laid in 3 layers. Finishing works including safety barrier, the centre reserve barrier, lighting, road signs, gantries, all the telecommunications. So there's a few other jobs that we have to do before we get the white lines down. We like to leave that to the end to make sure that it's fresh and clean for opening to traffic.
We can see in the distance the old A14.
Yeah, it's actually running today, but because it's reached over capacity, it's quite often stationary, and that's the whole reason why we're here.
To me, it smells a bit like a petrol station, but I've probably not got a very educated nose. Is that bitumen?
That would be the bitumen smell from the asphalt laying process, yes.
It's not my favourite. Do you like it? You must come across it quite a lot.
Yeah, we do, and I've become accustomed to it. I quite like it, actually.
Okay.
There's 3 materials in the industry that really bring on the closure of the project, which is topsoil, concrete and asphalt. And with asphalt, you can really smell the progress.
Julian Lamb there. And we'll be hearing more from Julian later on in the show. Now, it's widely known that air pollution is having a significant impact on human health. According to the World Health Organization, 91% of the world's population live in places where air quality exceeds its guideline limits. And every year, over 4 million deaths occur as a result of exposure to outdoor air pollution.
Well, air pollution is a complex mixture of gases and particles. When people talk about air pollution at the moment, they're generally thinking about traffic-related air pollution, although it's broader than that.
That's Chris Griffiths, Professor of Primary Care at Queen Mary, University of London.
The particles from, for example, burning wood and coal and so forth, other from diesel engines and internal combustion engines. Gaseous pollution, a mixture of gases, nitrogen oxides, nitrogen dioxide, sulfur dioxide, ozone, carbon monoxide and so forth. These vary in concentration in the atmosphere depending on climate, wind, sources of pollution and so forth.
So what is the evidence that links poor air quality to adverse health outcomes?
Largely comes from epidemiological studies, so large observational studies, but it goes back a long way. Now the evidence is very strong across the life course. The Royal College of Physicians published a major report a couple of years ago showing that before a child is born, right the way through to old age, air pollution is adversely affecting health, whether it's the development of the child in the womb, development of conditions like asthma during early years, stunting of lung growth, stunting of brain development, to in older life incidents of heart attacks, strokes, dementia and early death.
As Chris explains, it's not just the lungs that are affected by air pollution.
Pollutants which are inhaled are absorbed and are able to travel around the body and have distant effects. So soot particles get lodged in cells from the immune system in the lining of the lungs, and the greater the concentration of particles, the greater the adverse effects on the lung. But these particulates, particularly tiny particles, travel further, so they've been detected in the bloodstream, brain, and most recently in the placenta. The way in which they're adversely affecting health is not well understood, but it's likely to be a combination of deranging the immune system, causing long-term inflammatory effects within the tissues, which will deliver the observed effect.
Now, the exact mechanisms involved here aren't well understood, and there are potential confounding factors which need teasing out. But scientists are concerned that air pollution could have lifelong and developmental impacts. So, who is most at risk?
But one of the important things is that poor air quality tends to be visited on disadvantaged populations more than advantaged populations. So the health effects tend to be unequally distributed across the population. So disadvantaged people tend to live in more congested, densely packed areas, often closer to polluting roads and environments and so forth. So an important element of this whole drive to address air quality is to try to redress the health inequalities.
Now that we have some understanding of what air pollution is doing to our health, how much of this can be laid at the door of roads?
In London, which is primarily where we're doing a lot of our scientific work with our Breathe London project, we know that the last lot of data from 2016, which is all the verified data, shows that around 50% of the nitrogen dioxide emissions come from transport, so mainly passenger transport, that is diesel cars primarily. So we know that it's a significant issue.
That's Annalisa Allen Norris from the Environmental Defence Fund, an international charity who brings scientists, economists and lawyers together to tackle environmental issues.
Trying to divide this column of pollution, that's a difficult thing to do, but it's one of the things that the work that we're doing with our Breathe London project is trying to address. The technology and the science is very complicated, and it's also affected by weather, but there's very sophisticated modelling there that enables us to really tease out what these different sources of pollution are. If we know that, we can put in place regulations that tackle those individual sources.
The Breathe London project that Annalisa mentioned there is a 12-month project involving partners from a variety of different organisations, which aims to bolster the air quality monitoring infrastructure in London. The aim is to get a much better idea of air pollution exposure at a hyper-local level, which can then better inform policymakers about the effectiveness of interventions designed to tackle air pollution.
So London actually has quite a large network of reference grade monitors across the city. It's got around 100 in its main network, which is one of the largest of most cities. However, there's a lot of people in London and there's a lot of vulnerable populations in London, and there's not necessarily that hyper-local empirical data in each of those locations. A lot of the gaps are often filled by modelling, and obviously the more actual data that we can get, particularly in a sensitive location, schools, for example, around hospitals, that's really important. And that's kind of where we come in. So Breathe London's multiplying the number of sensors in that network in London, combining what's already there with a whole new suite of sensors. We've got an extra 100 new sort of state-of-the-art static sensors which measure various different pollutants. We've also got Google Street View cars, which are kind of jam-packed of all of these sensors, which are taking street-by-street measurements every few seconds across the city. And we've also linked up with King's College, and they have wearable sensors where school children and teachers are taking those sensors with them in backpacks on the way to school, so that you get a really local exposure measurement. we're making sure that this project is policy relevant. A lot of our fixed monitors are deployed at schools, so we're measuring pollution in areas where the most vulnerable populations spend their time at the most polluted times of the day. We're also looking at different types of populations, so high and low deprivation areas, and also really mixed areas in kind of major town centres. And we're seeing differences in street by street level, really.
For about a month now, London has had a 24/7 ultra-low emission zone within the central area of the city, where there is already a congestion charge. The ULEZ, as it's termed, adds on an additional £12.50 a day for vehicles entering the zone which are not compliant, so older diesel and petrol vehicles. So has this extra charge made a difference to air quality?
It's only been in place for sort of a month or so, and during that period of time we've had quite unusual days where the city centre might be cut off anyway. So we've had the Easter period where a lot of people would be on holiday. Also, we've had Extinction Rebellion and a lot of protests where the streets have been closed, and the London Marathon. So we've only got a few days to look at, and certainly the data that the Mayor's office has provided suggests that there's far fewer vehicles, which are the dirtiest vehicles, entering the city centre. Now, how that translates into meaningful pollution reductions is something that we're hoping to measure, and we're keeping a close eye on that, and we're hoping to be able to say more in a few months' time about that.
Crucially, Breathe London started collecting data prior to the introduction of the ULEZ, so they should be able to compare pollution levels before and after the policy introduction.
One of the key things is that we are also measuring carbon dioxide, which is not what the current London network does. And that enables us to some extent to correct for the uncertainty that we do have around these meteorological effects and the impact of the weather on the pollution that we see. So we can really start to attribute where that pollution is coming from. So we should be able to better inform the mayor and citizens generally about the true impact of the ultra-low emission zone and other smaller interventions that might be happening around the same sort of time.
Chris Griffiths, who we heard from earlier, is also working on investigating the impact of the ultra-low emission zone.
We're evaluating this by setting up cohorts of primary school children, both in central London and in a neighbouring large town with relatively poor air quality, that's Luton. Actually, in both those areas, we're expecting improvements in air quality because the general trend will be towards an improvement. It's likely that there'll be a larger improvement in London, and so we have two groups of children, one in whom probably be larger improvements in air quality if the ultra-low emission zone delivers what it's supposed to do. Over the next years, we'll be measuring the health of those children, so we'll be trying to demonstrate whether improving air quality prevents the stunting of children's lung development. That's a primary aim of the study.
In the carrot and stick analogy, discouraging drivers from bringing dirtier vehicles into central London is arguably the stick. So are there any policy carrots when it comes to air pollution?
It's something that plays on my mind a lot of the time. One of the things that new data and more hyperlocal data throughout the day can offer is better forecasting. So you can forecast for episodes of very high pollution, and that could be used to restrict access even more stringently to certain areas, whilst putting in policies such as reducing the cost of transport for those particular days, so that you're giving people an alternative means of transport so they don't have to get in their car, which might not comply with the restrictions. And we do see that happening in other cities such as Barcelona and Paris to an extent. Being able to offer people an alternative means of transport through either shared transport or better access to bus services is something that's obviously necessary for people who don't have cars that comply. There's also very little being done in terms of incentivising either citizens or businesses to transition to cleaner cars and vans. It's something that California has been doing for quite a while. The government could be putting in place market incentives that allow the industry to really progress so that the number of options for customers increases and is pushed forward onto the market, rather than continuing to incentivize people to purchase the dirtiest vehicles, which is what we're seeing at the moment. And certainly things like an interest-free loan, which is what the Scottish government did a couple of years ago, which is just finished now, which enabled people to actually get a new car, which is an electric car, interest-free with a loan. Those are the sort of policies that should be explored here. But we don't see much progress in terms of those sort of policies at the moment. It's something that's a real point of tension, and it's something that the government needs to be addressing, because if you're restricting access to the centre of a city, then you need to be able to offer to people means of transitioning to cleaner modes of transport.
Annalisa Allen Norris there, and you also heard from Chris Griffiths. And if you want to hear more about the technology used in air pollution monitoring, you can check out our latest In Short podcast, where I took a stroll around Cambridge with two chemists working on sensors to better understand air pollution exposure. You can find it on the Naked Scientist website, search in the In Short section, or on the podcast feed, which is Naked Specials.
Hi Katie, how are you?
I'm pretty snug, to be honest. Quite cosy in here.
The Naked Neuroscience podcast explores the workings of the brain and the nervous system in our bodies and beyond.
It does not mean that you need to be sophisticated on an instrument. You can just hack on the piano.
Wow, so I can legitimately tell my friends to shut up because I've just passed my driving test.
You have my blessing, yeah.
Do you want to know who you are? Can we actually understand how we think?
From lifting the lid on consciousness to remembering how to forget, join me, Katie Haylor, each month as we make connections with scientists and spark up conversations on the latest neuroscience news. Listen and download for free at nakedscientist.com/neuroscience or subscribe to Naked Neuroscience wherever you get your podcasts. On the way, what's going on underneath the cover of those traffic lights to help us get around the town? Now, if you live near a busy road, you may have been kept awake at night by the odd car rumbling past or a bus idling at a nearby bus stop. And it's not a trivial problem. How busy a road is, traffic flow and vehicle speed can all influence road noise. But what can be done about it? Ben McAllister spoke to acoustic engineer Laurent Galbrun from Heriot-Watt University in Edinburgh, asking, first of all, how noisy actually are roads?
There are surveys that talk about 125 million people that are affected by levels greater than 53 decibels in Europe. And within those 125 million, it's 37 million that are exposed to levels greater than 65 decibel, which are quite high. Environmental noise guidelines from the World Health Organization, they recommend not having levels greater than 53 decibels.
What does that sound like? What's a comparison there?
Well, for example, if you're talking to somebody just 1 meter away from the person, that would be roughly around 65 decibels. Remember, however, that obviously I'm talking about 65 decibel conversation if you're fairly close to the person to whom you're talking. Now, you would have roads further away, typically from your home, let's say, so you don't expect such high levels, and you don't want to have such high levels.
Right, so that's 53 decibels is considered acceptable at your home, not at the site of the road itself.
At the recipient, yes.
Right, okay. And how much noisier can roads be than that?
They are much noisier typically than that, especially in densely populated areas. In very busy roads, you can be above 80 decibels.
Why is it a problem if it's louder than that? What are the problems associated with noise pollution?
So it's fairly common for people living in noisy areas with large roads to be adversely affected in their sleep, and there are cardiovascular diseases. And there is now pretty strong evidence of, in particular, what is called ischemic heart disease. If you live in a noisy area, close to a noisy road, you basically are more susceptible to have ischemic heart disease.
Wow.
So there is an increase in the probability of you having that.
What are the approaches currently being taken to reduce the impacts of road noise on people?
There is noise control engineering, which is basically about looking at what you can do at the source first. So, for example, making vehicles quieter. The road surface as well can also reduce noise levels. Just the porosity of the asphalt will actually absorb the sound, so less sound reflected. You can do those things at the source, and it tends to be always the preferred approach, because if you reduce the level at the source, all the surrounding area will benefit from that. The next thing you can do is to reduce the noise along the transmission path. So let's say you put a barrier. Sometimes you might not even notice them, because often it's just soil that is put next to motorways. It's fairly common. And ultimately, you look at the receiver, let's say the house. What can you do at your house not to hear road traffic noise? And solutions will be typically things like replacing single glazing with double glazing. You can design buildings so that you always have a quiet area. So you always have bedrooms, living rooms, all the living spaces on the quiet area, and you instead have corridors, storage spaces, bathrooms on the noisiest areas, so the occupants are the least affected.
Are there any limitations to this approach? I mean, why can't we just do this everywhere?
The fact is that sometimes you can do as much as you can, or it's still not quite enough. Now, especially in very busy areas, city centers, there is just so much that can be done. And that's where you start thinking, okay, maybe the solution here is not about just reducing noise levels. It's about using sound as a resource rather than a waste, something that is good, that people like. And that's where you can use what we call positive sounds, such as water sounds. These can be used to actually mask the road traffic noise. And then you start basically focusing on the positive sound, and you finally end up just hearing really that and block out the noise. Classical approach is that you would want to have the very similar frequency content to cover road traffic noise. That would be called energetic masking.
That is to say, if you've got a really low frequency noise, like, say, a bus going past, you'd want something low frequency to try and cover that up.
Exactly.
What might that be?
You might need, for example, a very large waterfall, let's say.
Right.
That creates a lot of very large bubbles, that creates a lot of low frequencies. But ironically, from all the work I've been doing, you don't need energetic masking. You don't need to have the same frequency content, because ultimately people are drawn naturally to the sound they prefer, and that's called informational masking. So you might have a type of sound that doesn't match in terms of frequency characteristics the noise, but it doesn't really matter, because people will block out the unpleasant sound and will focus only on the pleasant one. So that's where perception is really important, and a lot of acoustic research currently is looking at perception and going beyond just physical parameters. So there are some studies that are quite interesting, because they show that when you add greenery, even if you don't reduce noise levels, there is a perception that the place is quieter. You are actually doing nothing from a noise control engineering point of view, but you're changing the perception of the space and you're making it more pleasant.
Man, human beings are weird, right? We'll really take some weird stimuli and let them change the way we see the world.
So if you're troubled by annoying road noise, perhaps getting some houseplants could actually help. Laurent Galbrun there speaking to Ben McAllister. And ironically, their interview was interrupted by noise from construction works next door to Laurent's building, but I didn't think you'd appreciate hearing that bit.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Today, we're revelling in the science of roads. We've heard how air pollution can have dangerous consequences for human health. But when it comes to roads, air quality isn't the only cause for concern. I heard more from transport engineering lecturer Richard Llewellyn from Edinburgh Napier University.
Some research was done many years ago looking at the causation factors behind collisions. One is the road itself, how it's been designed, what the makeup of the road is, the way it's laid out. The second one is the vehicle itself, so how well it's maintained. And the final one is the user. What that research has shown is that 95% of all collisions happen because of user error, human error. So that really has been the focus of everything we do. And in trying to address that, historically, we've had this approach called the 3 E's approach. One of education, getting the message across for good practice, such as wearing seatbelts, avoiding drink driving, and in more recent times, avoiding things like the use of mobile phones at the wheel. Secondly is enforcement. So this is something that obviously the police do. It's something that's essential, but it's of limited effectiveness. If we didn't have the police enforcing road safety, we may well have anarchy out there, but the more we have, it doesn't have a proportionate effect. And then finally, the last one is engineering, which is changing the road environment and the vehicles on it. More recently, we've moved towards something called the safe systems approach, which is looking at things holistically. It's looking at those three issues, but it's also looking at what everybody can contribute to them. So it's safe vehicles, safe use, safe speed, safe roadsides, and safe post-crash care, looking at the whole story of how a collision happens. And ultimately, what we're aiming for is Vision Zero, where no one is killed on our roads. And basically what we're taking in as a prime assumption here is that humans are fallible. We make mistakes, and that's really what we're trying to deal with, minimizing the damage that can be done when a human makes a mistake.
One thing that occurs to me when we talk about driver behaviour, mobile phones. Most people know that you shouldn't be holding a mobile phone and talking in it when you're driving. But some people use their phones for GPS. Some people will have a Bluetooth system or loudspeaker to have a work call or personal call whilst they're driving. What's the evidence around that? Is that any safer?
Marginally safer, but the evidence would suggest that any form of distraction within the vehicle is going to take your attention off the road. Now, you wouldn't have someone in a factory or a nuclear power plant, for example, operating machinery while they were talking on a phone. You'd want their full attention being given to that. And when you're driving a vehicle, it's exactly the same thing. And in terms of this safe systems approach, for example, in terms of mobile phone use, we're now looking at taking that sort of responsibility away from the driver, but also moving it on to companies. So many companies these days, for example, now have policies that if you are driving on business, you are not permitted to use your phone under any circumstances. This contributes to this safe systems approach. It's not just one person's responsibility. We all have a part to play in this.
So how do you get, just for the sake of argument, to your destination if you're using Google Maps on your smartphone?
Well, I mean, in terms of Google Maps and sat-navs, the use of audio messages through that, I mean, primarily it's the conversations, the thinking on the phone, certainly operating that sat-nav, making sure that sat-nav is programmed before you start that journey, making sure that it is hands-free, and also things like, you take regular breaks.
We live in an era that is ushering towards autonomous cars. We're not really there yet, but what we do see is increasing levels of autonomy in our vehicles. How much of that can we expect in the near future then? And is that going to make a difference to road safety?
Well, the most immediate actions that are being taken were outlined by the EU a couple of months ago. There was a political agreement in March of this year to add a couple of key things to vehicles that are produced and used in the European Union from 2022. One of those is something called intelligent speed assistance. It works using a combination of GPS, cameras, radar technology to determine the position of the vehicle, and it compares that with a speed limit map. Now, if the vehicle finds that you are driving in excess of the speed limit, there's a couple of options. It will either advise you you're doing so, or in ultimate circumstances, it may even forcibly reduce your speed. Another measure coming about, and in fact it's fitted on quite a few vehicles already, is this concept of an emergency braking system. This is a system that detects objects such as a vehicle in the road ahead, and if you as the driver don't apply your brakes in time, these systems will automatically bring you to a stop. So these types of things have great potential to really make a difference in terms of the number of collisions on our roads. But there is also potentially a negative side with these things. In the rail and air industries, for example, we found when automation has taken place to vehicles, actually drivers' attention or pilots' attention starts to wander as the mind has less to do. That can create other problems. So it's not by any means perfect, but hopefully a step in the right direction.
Is there another issue here in that these new cars that are coming in have these added safety features? That's great. But if the person behind me that goes into the back of me is in a really old model that isn't particularly autonomous, I guess there's still a risk there, is there?
And this is one of the big challenges, I think, over the next few decades of autonomous vehicles and how they're introduced. In a situation where an autonomous vehicle is completely free to do what it wants, we've got great technology. For example, Stanford University has just developed a race car that can be driven around a racetrack at speeds commensurate with that of a racing driver. It can deal with all sorts of conditions, wet conditions, and it's got really, really good detection systems. But you put that in a real environment where it's mixed with other vehicles and indeed human beings making decisions on that road, then you start to have a problem. Motorways, for the most part, are reasonably predictable. And I think, in the future, that's probably the first place that we will start to see autonomous vehicle use really started to take off. Perhaps we might see dedicated lanes to start with. When we move into the urban area, things get incredibly complex. Humans are unpredictable. And going back to that fact that 95% of collisions are due to human error, those vehicles start having interactions which really any amount of artificial intelligence is really going to struggle with. So dealing with pedestrians walking out into the road, interactions. I mean, if you or I were at a junction and someone flashed our lights, let someone out, we would know exactly what to do. But what would an autonomous vehicle do? And there's also a lot of other questions. A moral question, if an autonomous vehicle was in this situation where there were other vehicles and other users on the road and it had to take evasive action, what does it do? And who would be legally responsible? And there's other issues like cybersecurity, people starting to hack into vehicles. So there's a lot of questions that we really need to grapple with in the future. And arguably these moral and legal questions are just as tricky as some of the technological ones.
Plenty of food for thought there. Richard Llewellyn from Edinburgh Napier University. And we'll be hearing more from Richard later on. Transport is now the single largest UK source of emissions, accounting for a third of carbon dioxide output. Now, exciting new technologies are on the horizon which could help make roads greener and safer. But how do these new concepts actually get onto the busy highways they're intended to benefit? Well, using an 18-mile stretch of highway in the US, the RAY is a non-profit foundation who do exactly this. By testing out new tech on a large stretch of road, this organisation is working towards some lofty aims, including zero carbon, zero fatality roads. Adam Murphy found out more from Executive Director of the RAY, Ali Kelly.
We want transportation to become more advanced technologically because we need cleaner and safer transportation, particularly as it relates to carbon, because in the United States, the transportation sector is the #1 contributor to airborne carbon now. So these are huge challenges that present huge opportunities in the transportation sector. We believe that the technologies already exist for transportation to be zero carbon, zero deaths, and zero waste. And the goal of the RAY is to get those technologies into the interstate highway environment.
Now, a zero carbon road seems like a huge thing to get. So what kind of technologies are you developing that would get us there?
Providing the infrastructure for electrified transportation and consumer vehicles and with fleet vehicles should be our #1 priority. Our very first technology demonstration on the RAY in 2015 was solar-powered EV charging station. We wanted to provide the cleanest power possible for the cleanest form of transportation that we have at our fingertips right now. The RAY also has a partnership with a group in the United States working on wireless dynamic EV charging while you're driving in a lane. I feel like this is a breakthrough technology that will help electrification, particularly in the fleet environment.
How does the wireless charging when you're driving work?
You develop a magnetic field between the road and the electric vehicle underside, and you can transfer alternating current through that magnetic field.
Now, another thing you mentioned was a zero fatality road. How would you go about getting to that point?
Well, the technology advancement in the vehicles themselves are going to eliminate as many as 40% of all accidents and traffic-related fatalities in the United States. That's a conservative estimate. These advanced mobility technologies are autonomous vehicle technologies and connected vehicle technologies. And we at the Ray believe that in order to leverage the most benefit from these advanced mobilities technologies, we need to advance and modernize the road infrastructure too. 3M has designed striping that is visible for these new vision systems that are developed for autonomous vehicles. And then with Panasonic, we're developing the software to manage the data streams from connected vehicles. More and more vehicles in the United States and around the world are being developed with radio or cellular technology so that the cars and the trucks can talk to themselves. We're working with our Georgia DOT and with Panasonic to gather that information from the cars and the trucks and to pull that into a special brain for connected vehicle data that will manage the data, that will help to make sense and meaning out of the big data. And over time, the system can become predictive, and a special brain for connected vehicle data can allow you to incorporate machine learning so that your system can become predictive with that data set and with the machine learning capability. At the end of this year, we'll have the software and the hardware in place on the Ray to allow for the testing of platooning freight vehicles and vehicles with no human driver traveling at speeds of 70 miles per hour or faster.
So is that like convoys of cars all working together following machine learning to get where they're going?
That's exactly right. Platooning are freight vehicles traveling very close to each other so that they could take advantage of the efficiency of drafting in each other's space that reduces the wind resistance. And it also is a much safer way for freight vehicles to move from one place to another because it eliminates the space in between the trucks that other drivers might use as they weave in and out of traffic.
Are we going to need to do anything to change the makeup of the roads themselves?
We don't need, but we should, because right now we have the technology to recycle old scrap tires into asphalt roads. Every single human generates about one tire into landfills every year. And so the fact that we now know how to upcycle old tires into a road pavement that performs so well, durable, crack resistant, quiet road, it's a win-win situation.
Of all these technologies, what do you think is going to make the biggest impacts towards these goals of zero carbon and zero accidents?
There are technologies that we can utilize right now to solve simple, predictable, and preventable problems on our roads. And one of those technologies we believe is important immediately today is called Wheelwright, and it examines tires without any human interaction necessary. It's a drive-through piece of equipment, and it examines your tires for tire tread, tire pressure, and damage to your sidewalls. We know that tire failure and tire blowouts are the cause of fatalities on our roads, and tire blowouts make accidents more dangerous and more likely to be fatal. So it's a safety improvement to have better maintenance of your tires, but it's also an environmental improvement. When your tires aren't properly inflated and you have a gas-powered car, you're wasting fuel and your emissions are increased at the tailpipe.
Exciting stuff, and perhaps some of that tech will be coming to a road near you soon. Ali Kelly there from the Ray Foundation, and she was speaking with Adam Murphy. On the way, how can the process of making roads itself become more sustainable? We'll be finding out. If you're listening to this while stuck in traffic, you could be forgiven for thinking not much thought goes into controlling traffic in urban areas. But behind the scenes, highly complex systems are at work. Richard Llewellyn.
If you take any big city within the UK, pretty much all of them these days will have something called an urban traffic control system, controlling all of the traffic signals within that city. Now, traffic signal timings are set based on traffic flow. Historically, we did that many years ago just manually and taking an average on a particular day, but these days it's much, much more high-tech. So we've got detectors in the road and above the traffic signals. They detect the flow at any one time, and they adjust those green times that you see on a cycle-by-cycle basis. A traffic signal cycle is where we go from red to amber to green and back again. And when you're driving in a city, if you're driving on a main road into a city centre, what should be happening is you should be seeing some sort of linkage between those signals. So if you hit a green signal, then as you get further down the street, the timings should be such that your progression along that road is unimpeded. Now, unfortunately, it doesn't always work that way. It doesn't always seem that way because lots of different things are happening on our streets. Buses are stopping, people are delivering goods. The flow doesn't quite work as well as it should do. But there is a lot of intelligence within those systems that make those changes to try to get the maximum amount of traffic through. And they can also do clever things as well, like prioritize emergency vehicles, public transport, even respond to pollution. We have systems that can measure pollution and start to adjust the traffic patterns, adjust which streets get priority to try and maintain or reduce those pollution levels.
So I guess if you've got something like an organised parade and you've got days of notice, that's one thing. But if you've got an emergency services vehicle coming in, you might only have a few minutes of notice. So how quick are they at reacting, I guess, to the changing traffic conditions?
Well, they can actually make changes to the signal timings on a cycle-by-cycle basis. So every time those lights change, one amount of green time might be different from the next amount of green time. They tend to be more responsive in the off-peak periods when things aren't as busy. The problem with the peak period is basically our networks are so congested, there isn't a lot of slack, and the systems are very limited in terms of what they can do.
Considering that challenge, what is going on in the area of traffic control research to try and improve congestion bottlenecks or make journeys more reliable?
Yeah, well, I mean, reliability, that's the key word. People will tend to accept that congestion is a fact of life these days in cities. But what people find difficult to accept is that the journey time from day to day will change, and they might allow 45 minutes to get to a meeting one day and the next week it'll take them 90 minutes, and this is a real problem to people. One of the issues we've had historically is the ability to collect traffic data. We've been always reliant on roadside detectors or just traffic counts, but these days the number of people that are carrying around smartphones, that are monitoring where they're traveling to, how long it's taking, is a great source of data, and companies like Google, for example, now are providing journey time information which allows traffic engineers to start to build a picture of journey time information and start to try to react to that and at least disseminate it to those that need to know. Ultimately, though, the problem still remains that network is a finite resource, and we really need to question who should be using it and when. That's really the big challenge.
Considering that vehicles are becoming increasingly more autonomous, is this set to impact upon how we control traffic on the roads?
Yeah, well, I mean, autonomy brings with it some potential advantages in terms of driving style. It removes some of the unpredictability from the system. So if you imagine people driving along a motorway, one driver to the next, everyone leaves a little bit of a different gap between the vehicle in front. But if you have a machine in control of the distances between vehicles on, for example, a motorway, you've potentially got a much more stable flow there. There has actually been some suggestion that if we had fully autonomous vehicles, the need for things like traffic signals could be completely removed from our cities, in that the vehicles themselves would communicate with each other and that we wouldn't need this technology by the side of the street. But I think that one's quite a long way off.
As you're a traffic expert, I've got to ask, what is the best etiquette in terms of managing traffic flow if you come to a bit of a standstill on a motorway? You've got someone who's edging really close to you, someone who's trying to leave a bit of space, and there's always that person who will go in the gap. actually, for efficient movement, what is the best way to behave in that situation, assuming you're not in an autonomous car?
A motorway works at its best when you've got a steady state flow. Now, these shock waves and issues that occur on motorway, phantom traffic jams, they're sometimes called, occur when there's been some event that's happened on the motorway. Now, that can sometimes be something like an accident, but it can also be things like merging vehicles or someone changing lane or someone driving a little bit too close and braking. So if you want to adopt a good driving style and try to get the maximum benefit from motorways, the best way of driving is try to allow as much distance as possible from the vehicle in front to brake very gently within reason and to accelerate away very smoothly. And by maintaining that smooth traffic flow, it might not completely prevent that type of congestion, but certainly it would go some way to help.
How do traffic control systems make sure that if there's a diversion, traffic is being sensibly and evenly distributed? Because I guess what you don't want is to think, okay, that route's cut off. Let's send all of the cars in the city onto a different route and just cause a massive jam. How does that work?
Within traffic models, what the model will try to do is it uses something called the generalized cost of travel in terms of the vehicles on the network. So it tries to minimize the amount of delay within that network. So it will try many iterations to try to distribute that traffic as best as it can, minimizing that cost. And once it's found that solution, that is the form of diversionary route that will be assigned. Sometimes if we know of an event that's happening, we might manually put something in and come up with a plan in advance, but if it's in real time, that's the way it would work.
Richard Llewellyn there from Edinburgh Napier University. Alongside the roads themselves are the processes involved in producing and maintaining them. So looking to the future, how can road construction itself be made more environmentally sustainable? Back at the A14 construction site, I put this question to road building expert Julian Lamb, who we heard from at the start of the programme.
So we always try to minimise the impact that we have and eliminate things and reduce and recycle wherever we can. We have zero materials going to landfill. And we've had some solar-powered generators on some of our satellite offices. We've also been using some of our temporary lighting has been through solar power. And also we have made sure that our supply of energy for our main compound areas are through a renewable energy guarantee.
Is there anything that can be done to try and minimise the amount of carbon that we're using for things like cement?
We try to minimise where we can, and obviously the foundation layer to the pavement is just a granular, naturally occurring material. Ultimately, the materials that the traffic rides on, it needs a certain strength, and therefore, unfortunately we do have to use cements, we have to use bitumens, and then some of the structures, the spans that we have to cross, we have to invest in materials like steel. It's all essential in order to carry out the works that we have to do.
So what can be done then to try and minimise the environmental impact?
The planting of trees is certainly something that we're doing, and really just trying to minimise the impact through refinement of the design to make sure that we are meeting a specification but not going over and above what is necessary and therefore being heavy on carbon input to the project.
Looking to the future of construction, are there any big changes that you think we will need to take into consideration as we're moving towards a more sustainable way of living?
We're certainly already trying to look more and more at off-site construction and assembly. We're also looking now at autonomous plant. A few weeks ago we did a trial with an autonomous articulated dump truck. And that's something that I think we will see coming into the industry in the future. We have a shortage of operators and we have an increasing need for doing bulk earthworks operations. So the autonomous vehicle will provide that opportunity to fill the gap. As part of the scheme, we are in certain areas using very low noise surfacing in areas where there are people living nearby. That's reducing the amount of noise at source. We also have environmental barriers that sit on the extreme of the scheme to also try to reduce the amount of noise that's travelling past. But noise barriers will contain noise that is close to it, whereas The very low noise surfacing is reducing the noise at source where the noise is generated. The downside to that is the material that is used is not as durable as other surfaces that we might use, so it will need to be replaced more frequently.
Now, what about electric vehicles? They are becoming cheaper, they are becoming more accessible to people, the battery life is improving so we can do longer journeys, but a big criticism at the moment is the amount of charging stations. Are you planning to factor in any charging stations on the A14?
So the longer term plan for Highways England is to attempt to have charging points at approximately 20-mile distances along the strategic road network.
Got to ask, do you have a favourite road?
Yeah, any road that's moving.
Hear, hear. Thanks to Julian Lamb from the A14 project, and thanks to everyone else involved in the programme.
Hello, Chris here. I've just popped in to let you know about something very important, so please listen up. Now, as we approach 2020, we want to put The Naked Scientists on a sound financial footing for that new decade, and we need your help to do it. In fact, we need to raise £50,000, which is about 1/3 of our running costs, and at the moment, we're about 1/3 of the way there. We've managed to do that with the help of less than 1,000 of you, and we're very, very grateful indeed to those of you who have helped. But there are many more of you out there who listen and enjoy the programme every week, and we'd like to appeal to you for your help as well. Maintaining the quality of the Naked Scientists output is very labour intensive, and we do need to pay our hard-working staff who make such a good programme for you every week. So please, do make us a contribution. We've made it very easy to do that. You just go to nakedscientist.com/donate and you can leave us a message. You can also dedicate your donation to somebody if you wish. We'll read those dedications on air, and you can also read what other people are saying too. That's thenakedscientist.com/donate. thenakedscientist.com/donate. We sincerely hope that you can help. Thank you.
Next week, get ready for Extremes Month. We're kicking off June with extreme speed, from humans to cars and the epic speed limits of our universe. And if you're a fan of the show, why not leave us a review? We really love hearing your thoughts and feedback. You can get in touch via email. It's chris@thenakedscientist.com, or we're at Naked Scientists on most social media platforms. The Naked Scientist comes to you from Cambridge University and is supported by the EPSRC and Rolls-Royce. I'm Katie Haylor, and until next time, goodbye.